So collisions happen pretty much anywhere. So many kinds of collisions. There are car collisions, there are train collisions, there are running into your brother collisions, there are like, oh, you trip on something, you shoot something, like you shoot an arrow into something, that's a collision. Multiple kinds of collisions. In this video, there are 3 learning objectives that you will learn. 1 is how to solve for collisions. 2, you will learn that mass and momentum must always be conserved. And the 3rd thing you will learn is that the direction of an object during the collision has an effect on the end result. To solve for collisions, there are some vocabulary words that you need to know. You need to know mass, velocity, momentum, and kinetic energy. Mass is self-explanatory. Velocity is how fast it's going. Momentum is the quantity of motion that an object has. Kinetic energy is the amount of energy an object has while in motion. The equations that you will need in order to solve for collisions is momentum is equal to mass times velocity, and kinetic energy is equal to half times mass times velocity squared. The best way to solve for collisions is using MVP boxes. In the MVP box, you have the mass, the velocity, and the momentum. With MVP boxes, you are clearly able to see how momentum and mass are always conserved, because what is on the left side before the collision will always equal what's on the right side after the collision. This is a sticky collision example. So, the first object is at rest, which is what the dot represents, and it has a mass of 10 kilograms and a velocity of 0 meters per second. Now, because momentum is equal to mass times velocity, the momentum equals 0. And also, if an object is not moving, it has no momentum. For the second object, the mass is 20 kilograms and the velocity is -5. And it's negative because it's going in the negative direction, which is to the left, which makes the momentum also negative. The final object will go in the same direction that the second object was going. So, because mass and momentum must always be conserved, we can solve for the mass of the final object and the momentum of the final object. So mass 1, which is 10, plus mass 2, which is 20, is equal to mass final, which is 30 kilograms. And since momentum must always be conserved, momentum 1, which is 0, plus momentum 2, which is -100, equals momentum final, which is still -100 because the objects are still sliding into the negative direction. Then we solve for velocity, and velocity is equal to momentum over mass. So if we take -100 and divide it by 30, we get a velocity of a -3.33 meters per second. And again, it's negative because this object is sliding off into the negative direction. In order to solve for the kinetic energy, you need to know the equation for kinetic energy. And the kinetic energy is equal to its half times mass times velocity squared. Now for object 1, because the velocity is equal to 0, the kinetic energy is equal to 0, because kinetic energy is the energy that an object has while in motion, but this object is at rest, which means it has no motion, which is why the momentum is 0 and the velocity is 0, so the kinetic energy is also 0. And the kinetic energy for object 2 is half times mass times velocity squared. So we take half of the mass, which is 20, times velocity squared, which is -5 squared, and we get a total of 250. And for the final kinetic energy, it's half times mass times velocity squared, which is half times 30 times -3.33 squared, which is 166.34. So in order to demonstrate that there is a loss of energy sometimes during collisions, you use the equation. The initial kinetic energy plus the loss is equal to kinetic energy final. So 0 plus 250 is just 250. So 250 plus loss is equal to kinetic energy final, which is 166.34. So you solve for loss, and the loss is 83.66. With the use of MVP boxes, you are now able to solve for collisions, and you are able to see that the mass and the momentum of objects must always be conserved throughout the event of the collision. Also learned that the direction an object has in the collision has an effect on the end result. And now that's how you solve for collisions. We are done.